In this video, we're going to look at the difference between discrete and continuous data. Discrete and continuous data are both types of numerical data, but discrete data can only take certain numerical values, whereas continuous data can take absolutely any value within a range. This will make more sense when we look at it in context. First of all, let's have a look at this. The heights of people on a bus. If we went on a bus and recorded the heights of all the people on there, we would have data. Now, this data is an example of continuous data because somebody could be absolutely any height whatsoever. They don't have to just take particular values. Another way of thinking about this is that you can never measure height accurately. You could measure it to the nearest millimeter perhaps, you could maybe even measure it to the nearest tenth of a millimeter, but you can never ever measure it perfectly accurately. So even if you've got someone down as 123.47 centimeters, you know that really the person might be a tiny bit more or a tiny bit less than that, and you've only been able to round it to that level of accuracy. By contrast, the next question gives us an example of discrete data. We are now looking at the numbers of pets owned by households on a street. So we could go knocking on each door of every house down a street and ask them how many pets they have in their household. Now, people are either going to answer with 0 pets, 1 pet, 2 pet, 3 pets, or so on. Nobody's going to have 2.75 pets. So this data can only take particular values. In this case, it can only be whole numbers. So this is an example of discrete data. Looking at C, we're now looking at the numbers of correct spellings achieved on a spelling test by students in a class. A spelling is something you've either got right or wrong. So the number of correct spellings you're going to have is either going to be 0, 1, 2, 3, 4, all the way up to the total number of questions on this spelling test. So here we have discrete data. It is only possible for students to score particular values, in this case a whole number of marks. Students aren't going to get 7.24 on their test. Looking at part D now, we have the masses of babies born on a particular day in a hospital. Like height, we can never measure mass completely accurately. We might be able to measure something to the nearest gram, we might be able to measure something to the nearest 0.001 of a gram, but a baby's mass could take absolutely any value within a certain range. The possible masses aren't going to jump from, let's say, 2.2 kilograms to 2.3 kilograms. A baby could be anything in between. It could be 2.24, it could be 2.247, it could be 2.2479. There are infinitely many possible values for the mass of a baby, and it would be impossible to measure accurately. So here we have continuous data. In the next question, we're looking at the times taken by a group of athletes to run 100 meters. Again, time is something that you can never measure accurately. You might be able to measure something to the nearest hundredth of a second on a stopwatch. At the Olympics, they might be able to go to the nearest thousandth of a second. Scientists might have clocks that can measure even more accurately than that. But the fact is, you reach a limitation. A runner is not limited to achieving particular times on the 100 meters. For example, they're not forced to achieve either 9.61, 9.62, 9.63, 9.64 seconds. They could achieve absolutely anything in between those as well. They could get 9.613, they could get 9.6135, 9.613728. There are infinitely many possibilities in there, so this is continuous data. Finally, we are looking at the shoe sizes of people in a room. Now, there aren't that many shoe sizes. You can't get a shoe size of 2.345. You can only get generally whole number sizes and half numbers as well. So you could be a shoe size of a 7 or a 7.5, an 8, an 8.5, and so on. The fact that you can have half sizes doesn't make this continuous data because you can't have anything in between those half sizes. Therefore, this is discrete. The point of this example is to show you that discrete data are not always whole numbers. In this case, you could be a shoe size 8, you could be an 8.5, but you can't be anything in between.